Hello and welcome. My name is Constantin. Thanks for joining today's session on how to configure your SCEPman instance to make use of SCEPman's self-service enrollment feature, which allows your users to retrieve certificates themselves without requiring any administrative assistance. The way this works in SCEPman is by using EST, which is short for Enrollment over Secure Transport, which in comparison to the SCEP protocol is a bit younger and allows us to freely choose the way of authenticating the users by not relying on content encryption, which SCEP is doing so by encrypting the requests in a PKCS7 package. All right, then let's get started and take a look at the different configuration steps we need to do with your SCEPman resources in your Entra and Azure tenant in general to allow you to make use of this feature. Let's begin and navigate to your Entra portal and search for the SCEPman API app registration, which is the default application you get when configuring a fresh SCEPman instance, which I did here already. To allow the module to come out with as little parameters and information from the user as possible, we need a way to identify the application in Entra without giving in the application ID. To do so, we take the URL of your SCEPman instance, which directs you to the homepage of your SCEPman instance, and add it to the branding and properties section of your SCEPman app registration. The next thing we need to make sure is that we are actually able to retrieve an authorization token, which we can do in the Expose an API section. Let's create a scope your users can consent to. Choose some description for the scope, which your users can then identify what they are actually doing. Great. Let's add the scope. And then, as the module we'll be using later relies on the Microsoft Azure PowerShell module, we will need to allow this specific globally available Microsoft app to authenticate with our SCEPman API app registration. To do so, we simply add the client ID of this Microsoft application and authorize the scope we just created. Great. Then all we have to do in the app registration or the SCEPman application itself is to actually permit a user to use the self-service enrollment. For this, we navigate into the enterprise application instead of the app registration and navigate to the users and groups section and search for our user and add them to the CSR self-service role. Great. With that configuration being in place, all we have left to do is tell SCEPman to really listen on the EST endpoint. For this, we go to the app service of SCEPman and check on the environment variables. All relating variables we are creating now relate to the DB CSR validation endpoint, which we currently don't have any settings for, but that's why we are here today. Let's begin with the first variable, which resides under the DB CSR endpoint, which simply is called enabled. It does nothing else than activate the endpoint, and of course we want to do that. Just add true as a value and applied. The second variable we need to include is the allow renewals, which also enables us to make use of the EST renewal endpoint. We also add true as a value in here and apply it. If you noticed that we have two lower dashes as a delimiter in this variable, don't worry. This is just because our example instance is running on a Linux ASP or App Service Plan. If you are running SCEPman on a Windows App Service Plan, you will have to use the colon for a variable delimiter. But the portal will tell you so if you do the wrong way, so that's fine. Then we just have one variable left, and this also relates to the renewal, and it tells SCEPman what certificate types we can actually renew. In our use case, this is the Intune user certificate type. But you can also renew certificates of the type static or Intune device, for example. Let's apply those changes and quickly restart the app service to apply the settings. Perfect. Now all we have left to do is actually try to retrieve a certificate ourselves with the user we just permitted to use the self-enrollment feature. For this, we open up a PowerShell session and make sure that we are installing the SCEPman client module. I already done this for this shell session, so we can skip that. But you would install it from the PowerShell gallery just like you would install any other module. You probably have done in the past this already. And the next thing we have to do is utilize the new SCEPman certificate, CMD-led, which allows us to use the self-service enrollment feature. The information we need to do so is the URL we added before to our app registration to find the SCEPman instance, and this will also be the destination where we actually send the CSR later on. So in that case, we can use the app SCEPman contoso.azure websites.net, and the other information we are required to provide is what content the certificate should have. As we are talking about self-service enrollment, we naturally want to have some identification of a user in there. This can be easily done if we provide the subject from user context. What this will do is after we authenticated the user, we'll take the display name and the UPN of this very Azure context and provide it in the CSR, which we can then sign with SCEPman and retrieve a user certificate for. Let's just quickly test this. Let's remove the administrative session and let's get started with that one. You see, after running the command, an Entra authentication window is automatically opened and we can choose the user we want to authenticate with. Of course, we want to select the user we permitted to do so. The authentication is now complete and we can return to our PowerShell window, which has already the certificate we tried to receive. You see, we automatically get a certificate with client authentication as an extended key usage. We have the display name of our user in here, and we can also by default see the thumbprint of this certificate. This is great, but now this certificate only is stored in the PowerShell pipe, which doesn't really make any sense as we cannot use it for anything. So if we, for example, want to store that certificate in a user key store in Windows, we can simply add the save to store parameter and select the current user key store. If we now run the command again, we will reuse the authentication context of the last execution and do not need to further authenticate our user anymore. Let's check in the user key store on Windows, and we see we already got a perfectly fine user certificate. Let's now talk about certificate renewals, as this will be a major part of a real-world scenario where we want to handle user certificates on any kind of devices that we cannot properly manage in Intune, like unmanaged Windows devices or Linux devices, for example. A simple way to automatically renew certificates we just created in that way would be to create a scheduled task which runs a script that will check for user certificates that will expire in a given amount of time and use the information of those very certificates to run the same command we just did. But the difference is, with an already valid certificate, we can also authenticate without providing any Azure context. So, let's create a new scheduled task and give it a name. For a trigger, we can simply run the script on a regular basis. We can choose daily, which doesn't result in too many certificate requests, as we are locally checking if we actually need to renew the certificates. For the action, we run PowerShell.exe and provide it with the script we have saved at a location we can access. You can also modify the conditions of this task to your liking. But for this example, this should be fine with the default settings. Let's now take a quick look at this very script and see what it does. You can see the main part of the script is running the new SCEPman certificate CMDlet as well. But instead of providing a SCEPman URL to authenticate to or to find the application we want to authenticate to and to actually send the request, we only provide a certificate. That way, we can read from the AIA extension where we need to send the CSR request. And like I already mentioned, the authentication part of EST is a little different to the way SCEP requests were authenticated. And we can use the certificate to do an MTLS authentication, which mutually authenticates our client as well as the SCEPman server and builds up an HTTPS session. In the upper part of the script, you can see that we are taking all the certificates of our current user key store and searching for the ones that are originating from our very SCEPman instance. In the next line, we also filter for the expiry date of the certificates. In this example, I've taken a really huge number because I want certificates to actually be renewed. In a real-world scenario, you will probably choose a number between 30 or 60 days, depending on your liking. After the certificates are renewed, we can also do a little housekeeping and remove the certificates that we've used for authentication. With a little PowerShell snippet, we can see what specific certificates originate from our very SCEPman instance. So let's take a note of this thumbprint of the certificate before running the scheduled task. we see that the operation completed, which should result in us seeing a different certificate now. And indeed, we can see the thumbprint we've seen before is different to the one we have now in the user key store, which means we renewed the certificate using EST renewal, and we also removed the old expiring certificate. Well, that's all for today. I hope you enjoyed this quick guide on how to set up SCEPman for the self-service enrollment feature, and I'm looking forward to the next session.